So without further ado, Chris, I'd be absolutely delighted to hand over to yourself and give you your 20 minutes to inform us about Opex and your offering.
Well, thank you very much, Martin, and hello everyone out there in the ether. As Martin said, I'm Chris Ayres from Opex Group, so good morning everyone. I'm pleased to be here today to present this Tech20, which focuses on how we can make use of asset data to drive down carbon emissions from oil and gas operations. But first, I wanted to start by setting the scene. Climate change is said to be the biggest threat facing our planet and the defining issue of our time. Experts agree that we need to transition to a lower carbon future or face dire consequences. Now, decarbonisation of the energy sector will require action on a global scale. And if there's anything to take from the events of 2020, it's the realization that widespread global change is possible if we want it, or indeed need it enough. Some of the brightest minds are working on the energy transition, with several game-changing low-carbon solutions in the, pardon the pun, pipeline. But these solutions are not yet fully developed or deployed. Over the past 5 years, wind and solar energy have grown to nearly 10% of the energy mix. But for now, society still relies on fossil fuels to power around 80% of our high technology lives. So the oil and gas industry still has an important role to play in the energy mix. But we are now an industry in transition, and we must do everything we can to limit the environmental impact of our operations. Many of the large oil and gas companies are setting out their visions to transition to integrated energy companies. In the past few weeks, we've seen BP, for example, announce that they are increasing their low carbon investment to $5 billion a year and upping their renewable capacity 20-fold. Earlier this month, the OGA published their Energy Integration Report, which states that UKCS activities can deliver 60% of the UK's decarbonisation targets. Almost a third of that can be achieved through the integration of oil and gas production with renewable energy, carbon capture and storage, and hydrogen, whilst offshore wind, wave and tidal projects could contribute a further 30% towards the UK's net zero target. At Opex Group, we care about helping our customers transition to the lower carbon future, but we also want to help them to maximise efficiency and minimise their environmental impact today. We do this by providing applications and services that transform asset data into meaningful, actionable intelligence that helps people to make the right decisions and take the right actions at the right time. Now, this all started 5 years ago when we built a data analytics platform that helped our customers to improve plant reliability by using their asset data to predict equipment failures in advance so they could avoid trips and the associated production losses and maintenance costs. Since then, we've been on a journey with our customers to broaden this platform, and our team have built a number of new applications so that we can also help to optimize the performance of systems, help them move to a more predictive maintenance regime, and solve very specific problems and challenges. Around 18 months ago, we recognized that whilst minimizing emissions wasn't a primary aim of our products and services, we were inadvertently, if you like, helping to reduce environmental impact by avoiding trips, limiting flaring, and ensuring all production operations are executed as efficiently as possible. Now, in some cases, a trip can expose an asset to 500 times more emissions than during normal operations. And even with quick turnarounds, the cost to the environment is significant. But this got us thinking that we had a real opportunity and all of the tools at our disposal to help our customers achieve their environmental goals, not just by helping them to avoid trips, but by making use of the same asset data so they can pinpoint the day-to-day operational actions they can take to maximize efficiency whilst also minimizing emissions. We all have a part to play in driving a lower carbon future. For many of us, that takes the form of the day-to-day choices and decisions we make in our personal lives. Do I take the car or walk? What am I doing to help minimize food waste, for example? And I'm sure that everyone has a plan to reduce energy consumption in their homes. But for those of us who work in the oil and gas industry, and particularly those directly involved in the production of hydrocarbons, the daily decisions that they make at work can have an even bigger impact. So how do we ensure that those decisions and actions are the right ones? It's great to be part of an organization involved in the energy transition, but it's even better to know that you personally are part of it. OGUK has estimated that we can reduce carbon dioxide emissions by about 10% immediately through operational efficiencies and improvements. And that's right in the sweet spot of the application of predictive technologies that I've described earlier. And a 10% saving across the UKCS equates to about 1.46 million tons per year of carbon dioxide, which is the equivalent of taking 280,000 cars off the road or planting 24 million trees. Now, that's something we wanted to be a part of, and it inspired us to build something that would help our customers to realize that 10% reduction in carbon emissions. So we set our minds to building a data analytics platform that would solve this particular environmental challenge. We've spent a huge amount of time getting this to work, and I can assure you it isn't an easy challenge to solve. To start with, we brought together a multidisciplinary team made up of process engineers, environmental advisors, and people with asset management experience who understand the problem and who have the domain expertise required to create a solution that is bespoke to the complexities of oil and gas operations. We added a team of data scientists to the mix with their advanced toolbox and the capability to apply artificial intelligence and machine learning so we can transform vast amounts of data into the intelligence we require. And then we brought in our software development team to bring this to life through interactive dashboards and displays that are easy to comprehend by everyone, not just engineers. But only the right people with the right knowledge, skills, and expertise can come up with the right solutions. And what we've come up with is an AI-driven platform called XPass Emissions that transforms asset data into meaningful intelligence so oil and gas operating companies can drive down carbon emissions. The power of data and data science is that you can put the right information into the right people's hands so they can make a difference. But a challenge like this can't be solved by technology itself. It requires a combination of technology and people. Not only does the industry need clever technology solutions, but we also need to drive cultural change and awareness so that the intelligence is translated into action and therefore, most importantly, results. XPass Emissions is all about reducing environmental impact, optimizing energy consumption and flaring, and reducing costs by driving cultural awareness and change. Now, it's an old adage, but in order to manage something, you have to measure it. The foundation of XPass Emissions is being able to answer the following questions. What are my carbon dioxide emissions right now? What is the lowest level of emissions I can achieve right now based on my current plant configuration and production targets? And if there are any excesses, what exactly is causing them? And crucially, what can I do about it? How can the intelligence that has been uncovered within the data be turned into action so that any unnecessary environmental impact can be mitigated? By pulling together sensor data from across an asset, oil and gas operators can quantify in near real time how much carbon dioxide is being emitted, not just at an asset level, but broken down by system, equipment, and key power consumer. Now, this granular picture allows asset teams to pinpoint not only how much carbon dioxide they're producing, but also where these emissions are coming from. So it's useful to understand what your current emissions are, and that's a great start. But what's much more powerful is understanding what the lowest possible emissions are at any given time based on the current plant conditions and your production ambitions. Now, this is not an easy calculation. In fact, without the use of data science, engineering simulation, and artificial intelligence, it's difficult to do once, and to be frank, impossible to do on a continuous basis. By taking huge volumes of historic data based on current operating mode, the available equipment, production targets, and levels of redundancy, it's possible to calculate what an asset's lowest achievable emissions are at any given moment. And by comparing the actual emissions with the lowest achievable emissions, allows us to pinpoint where any excess emissions are coming from. At an asset level, and all the way down to the key power consuming equipment, users can now clearly identify an opportunity, and these opportunities add up. By making use of the data, we are bringing new information, allowing the on and offshore teams to ensure that the emissions consequences of their actions are a key factor in their day-to-day decision-making process. And using the very latest in descriptive and predictive analytics, all this information is available at the team's fingertips. Understanding what's happening, why it's happening, and specifically where the opportunity exists to make a difference becomes part of the day-to-day. Here's a few examples of how this works, from insight to action. Now, take system startup, for example. Achieving production stability has always been the core focus, and the value of doing that quickly has been measured only in the barrels of oil equivalent we can produce, until now. One of our customers has a standard gas plant startup procedure, whereby they have the recycle valve manually set to 25% to ensure the system achieves production stability in a reliable and consistent way. But if the recycle valve is left in manual for too long, the system continues to run at higher emissions intensity than required. Now, using the XPass emissions platform, the asset team were made aware of this inefficient operating condition and were alerted to return the recycle valve to auto, ensuring the target production volumes were still achieved, but crucially at a lower emissions intensity. Now, this single intervention not only reduced environmental impact, but also saved the asset nearly 5,000 euros in EU ETS costs in just one day. In another example, XPass emissions highlighted that load sharing the gas turbines during startup and operating in dual train mode across the oil export pumps was delivering approximately 180 tons per day of excess carbon dioxide into the atmosphere. Now, that's the same amount of carbon dioxide in a single day that 10 households in the UK emit in a whole year. But having this new insight allowed them to make decisions in real time, to assess the operating risk in a new context and deliver production volumes, decreased emissions, and, importantly in the current climate, a reduced operating cost. The data platform that we've built is fully customizable to each operator and asset. We've learned over the past decade of working in this sector that the complexities involved in oil and gas operations mean that one-size-fits-all solutions rarely work. In the UKCS, we have a huge diversity of operating assets, with those commissioned in the 70s and 80s, connected through export pipelines to those commissioned over the last 5 years. Developing an understanding of an asset's unique operating philosophies and operating modes is crucial to building that full picture, helping to identify the opportunity from the highest asset-wide level all the way to the specific equipment, including any degrading efficiency and evadable redundancy. Now, as with any application of data science and analytics, once you scratch the surface of the data, this often leads to a wealth of insight and opens up a raft of opportunities to look at other areas to improve or solve challenges. Oil and gas operators are already using predictive analytics to improve the reliability of their systems and equipment so that they can reduce trips, which are a large contributor to flaring. And it's also possible to minimize stops and startups, again, key contributors to flaring and excessive fuel gas use. The work we've done to develop the expat emissions platform has led us to some really interesting insights into how the same data can be used to help our customers to, for example, optimize their gas lift, their system startup, different plant configurations, and indeed to address sort of standard performance degradation of the equipment involved. In fact, ongoing discussions with one customer at the moment has already identified a $1.3 million prize per annum on a single asset. And often, when we can solve a specific problem for one customer, this throws up solutions, tools, and applications that can be customized and rolled out to other customers and assets, benefiting the industry as a whole. So by looking at this holistically, operators have the potential to make an even bigger impact, not only to the environment, but also to the bottom line. And this type of digital technology can be introduced with no capital expenditure, and the subscription or license costs are easily offset against savings in EU ETS and fuel gas alone. I mean, even for assets that are heading towards cessation of production in the next few years, the operators have an opportunity to reduce their environmental impact, whilst also reducing their operating costs right now. In conclusion, we know that asset teams need to focus on achieving and maintaining production stability. But through the deployment of digital technologies like expat emissions, the industry can now set our ambitions higher and broader. Data provides the intelligence needed to make sure that every decision made about offshore operations can be done through the lens of both production and emissions intensity. The strategic vision of our industry to support the energy transition can be directly connected to the day-to-day decisions we make on and offshore. We all have a role to play in our industry's success, to move from energy to cleaner energy, and ultimately to the cleanest energy. Thank you very much.
Thank you, Chris. That was a fantastic presentation within the 20 minutes, which is absolutely perfect. The slides were really clear, concise, Absolutely brilliant. So I'll open the floor now for Q&A. Just feel free to either type in your questions or raise your hand if you have one. I'll maybe start with one from my side. I mean, you mentioned the 280,000 equivalent cars impact that we could have in the UKCS. Have you made any estimate of the potential global impacts? I guess this has got global offshore applicability as well as onshore.
I haven't actually got any sort of numbers to hand, but obviously the great thing about the application of data is that it can be sort of, just as I said, deployed equally across the UKCS, but also there's nothing to stop it from being deployed in any other basin around the world and delivering, I guess, that immediate value to operators wherever they're based. And of course, again, in the current climate, because it's data driven, you know, any constraints that you might have associated with the current sort of I guess working conditions are overruled effectively, because it's perfectly suited to a remote working application, and you can deliver that value wherever you're based in the world remotely. So I haven't got the values, but certainly the opportunity is significant.
Yeah, absolutely. There's a huge host of installations this could be deployed on. Got a question on the impact, Chris, in terms of installing what technology you need in an offshore platform. Can you tell us a little about what's involved and what the timeline is like?
Yeah, so actually, this is the interesting thing. So we've been having conversations with a variety of different customers for many years now about, I guess, data acquisition. So this is sensors that are available offshore on the asset, and I guess data analytics is data hungry, and having access to that data at source is sort of fundamental to I guess a high quality insight output, if that makes sense. What's really interesting about this service that I think differs a little bit from some of the operational tools and services that we've deployed over the last 5 years is actually that the data that we're using, we found, is much more readily available. So it doesn't need to have the very latest in data acquisition and transmission. What we found is that actually some of the oldest assets, certainly in the UKCS, have most of the information that we're looking at that we need to help build a customized model, an emissions digital twin, if you like, for their asset. So notwithstanding the sort of advances in technology, you know, things like plug and play gateways that can connect up to 4G and Wi-Fi zones, but actually the data density and actually the data quality that we've done on our assessments with customers and prospective customers has indicated that this is already readily available, as I say, across a broad spectrum of different ages of asset, which I guess is probably the only way I'd like to describe and differentiate them. But you're really looking at, you know, I guess some sort of fairly fundamental data points, so mostly process related, which are widely captured and available in historians. You're also looking, I guess, at some sort of metering data that's again often readily available because it's required for reporting purposes to statutory bodies. But what we've also found is, again, that the 5 years of experience that we've had working with these kind of technologies is using the combination of engineering subject matter expertise and data science and access to a wealth of historical data and the machine learning capability. You can also build quite reliable virtual instrumentation that can certainly account for any smaller blind spots that you happen to have and find yourself with when you actually get the data off the assets in question. So there's a number of, like I said, broadly speaking, the data's of a pretty good standard quality and availability, but actually there's a number of ways that we can reliably and consistently and in real time, I guess, close some of those blind spots.
That's great, thanks, Chris. We've got a question from David Wilkinson. You've maybe sort of partially answered that, but David, I'll unmute you. It'd be great if you could ask the question yourself, if that's okay. Or at least I'm trying to unmute David. Maybe you can help me in this one, Hannah.
He'll need to accept
Yeah.
it, Mark.
I was wondering if you could describe an example of what data you use and how you use it for optimization purposes.
So I guess that's a very sort of broad question. So we're using, I guess, telemetry data off the process and equipment to provide that overall picture of how the emissions is, or the key contributors are to the emissions. In terms of our optimization work that we've done with customers, driven from some of the insight that access to the broader data landscape has given us. You know, we've also done some optimizations, as I said, in gas lift. And again, the great thing about the application of data science is that it's sort of an agnostic tool set. So we work with telemetry data, we work with sort of unstructured data associated with maintenance events, starts, stops. We also work with some, I guess, slightly abstract data in this context, like crews and crew performance. So in terms of gas lift optimization, which obviously has an impact on the throughput of your gas compression system and subsequently the load required to deliver that throughput. We've actually identified sweet spots within the gas lift process using our, I guess, access to this data, machine learning capability, and working closely with subject matter experts in this area within Opex and our customers to identify these sweet spots, how they differ from, you know, crew to crew, what what's driving those sweet spots, set point changes, and the like, and actually being able to provide a really clear picture of what the opportunity looks like, and subsequently what the value proposition is to sort of take the action that will deliver that change and that ultimate value. So that's one example, I guess, from an optimization perspective. I think, you know, as I said, the telemetry data, it doesn't need to be, I guess, incredibly. I'm just looking at sort of data density levels, for example. So what we found for some sort of operational analytics, the more data density you have, the better in terms of equipment and process, mechanical data, that sort of thing. But for the emissions platform that we've developed, you're really just looking at a few key, I guess, equipment data points, motor load, for example, as well as the key process performance characteristics. And again, using some conventional, the combination of conventional engineering applications to identify I guess the drain, the load required to deliver those volumes, allows us to build that sort of aggregated picture and to optimize the overall plant configuration.
Well, thank you. That was very helpful.
We've also got a question here from Ernie Lambs. Ernie, I'll just unmute you so you can ask that one personally as well. It's always good to ask it in your own words.
Can you hear me okay?
Yeah.
Hi, Ernie.
Okay, I was just referring back to your example, the one about the recycle valve and returning it to auto after or as part of a startup process. Is that not just good operational practice that you would expect your experienced operations staff to do as a matter of course? And is there a basis for your approach to kind of highlight where perhaps training is a little bit deficient, and there might be a requirement for additional training for staff to help them achieve that good operational practice that would be expected of them?
I'm going to answer this as politically as I can, Ernie, but broadly speaking, I do agree with you, right? So the interesting thing about that example is you're absolutely right. It is sort of standard operating practice to return the valve to an automatic mode, right? I guess that there are two sort of uncertainties there. One, the decision when to return it to automatic is at the moment at the discretion of the shift production supervisor, for example, and in consultation with the control room operators. Now, absolutely, you would expect that a level of experience to inform that decision-making process. However, when the only driver you have is production stability, because that's the only thing that you're being, I guess, that's being flagged to you as part of your the dashboard that you use to make those decisions, then the urgency to return it to, I guess, most efficient operations is not necessarily, I guess, visible, if that makes sense. So that's the first thing, and you're absolutely right. I guess an experienced production supervisor might be, or probably is, factoring in the cost and emissions impact of running the gas compressor in this mode. But again, it's a sort of indeterminate decision-making process. It's all done, you know, and it's dependent on shift supervisor, and it's not done in sort of, I guess, fully transparent way. I mean, the other thing to factor in is that, you know, the industry is going through a transition. You know, we've been through some challenging times over the, well, I don't know quite how long it's been. It feels longer than it probably is, but certainly the last 10 years have been very challenging for the industry. And actually, you know, the demographics have changed, and we've lost, I guess, quite a lot of very specific subject matter expertise from the industry. And what this does, I guess, is it helps to bring that decision-making process front and center, bringing all of the key components to that decision-making process, and bringing emissions intensity right into the decision-making process, so that we can have and operators can have a conversation more openly about the consequences of these actions. So if you decide, as an experienced production supervisor, to sort of sustain a manual stop on the recycle valve, you're doing it in full knowledge that every sort of minute that you do is incurring this excess emissions cost and environmental damage.
Okay, thanks very much for that. That's a good response. It strikes me that you're kind of facing the need to change the culture of the ops staff, because, you know, up until now, you know, mission one was don't let the plant trip. Now you're saying don't let the plant trip, and by the way, reduce the emissions. So you're making their job harder, and I guess they need as many tools and support mechanisms as can be offered to them to allow them to do that job effectively.
Yeah, and that's a really good point. And I think actually some of the feedback that we've had is that there's been a little bit of a frustration within an organization. So there's a couple of things. One, the C-suite have been very vocal for all the right reasons about their ambitions to achieve net zero in line with the ambitions of the industry and the country as well. And that's great. And a lot of operators have set very visible external and internal targets that will have ramifications on, I guess, ultimately the remuneration of the employees within that organization. Now, the frustration that we've experienced, and I'm speaking anecdotally here, is on a couple of levels within the organization. So firstly, I think it's safe to say that, you know, everybody, broadly speaking, cares about the environment. And you know, as I mentioned before, we're all doing bits and pieces in our own lives that are, you know, actively, I guess, contributing to that energy transition, whether we're reducing waste or reducing our own personal energy consumption. So there's a desire to want to be involved, but also there's a frustration that, you know, that these targets have been set, and the people at, you know, within the operating envelope are not really able to take action. They don't have the information. They don't have the explicit capability to bring emissions and emissions intensity into their decision-making process. So it's sort of a, you know, as you say, the industry has built itself up to make sure that everything you need to know about production and production volumes is available so that you can make the right decision about that. But, you know, so it is a journey, it is a cultural journey, but bringing this information into that decision-making process, to be frank, just like the journey we've been on and continue to go on with HSE, you know, it was production at all costs, and then it was, you know, safe production. And now, to be honest, it's the same transition that says it's safe and environmentally sound production. And that's, you know, we've done it and we've demonstrated that we can do it, but what is required is putting it front and center, from the ground all the way to the top. And I think there has been a top-down approach, but what we're looking to do is fill that void, or help customers to fill that void on a day-to-day level.
Okay, thank you.
Right, thanks, Chris. We've got a question from Jason Patterson on the data that you use, Chris. I'll let Jason ask that himself.
Hi, Chris, can you hear me?
I can, Jason.
Hi, Chris. Great presentation. Thanks very much. Excuse my ignorance and apologies if you did cover this before, but just wondering about the data that's being used here. Is this data all readily available and published by operators, or is it highly confidential? I know there's often kind of some reservations around operational data. Just thinking in terms of, you know, obviously anything with machine learning, the more data, the better kind of end result in theory from the output of your algorithms. So, you know, is the data there? If it's not, why not? And, you know, does something need to be done to make it more readily available so we can make these efficiencies?
So I guess there's a couple of things. So I talked already a little bit about the sort of, I guess, the telemetry data that's used to sort of build the customized software platform for each asset, and is used to drive that platform in real time. You know, delivering that the descriptive and predictive analytics day in, day out. So that telemetry data exists, and to be frank, it is increasingly available wherever we go. And I think, you know, I think it's safe to say that customers have broadly accepted that giving access to this data to well, democratizing it within their organizations, but also giving access to the supply chain is of benefit to them. So that's the first thing, and we've seen no issues there. I guess the flip side, in terms of, you know, statutory reporting, there's actually quite a lot of transparency around I guess the high level emissions targets and certainly actuals that have to be put in place to meet the statutory requirements. And I guess what we've found is that working with customers, they've been very transparent in how they aggregate those numbers into those reports, which is at the moment done, broadly speaking, once a quarter, once a year, in some cases monthly, to give some indication of the total emissions that would get aggregated up. And assumptions have to be made, and in some cases we can help them with those assumptions and possibly eliminate some of those assumptions because of the granularity of the data that we're looking at. And in other cases we're I guess working with them to make sure that where we have to make assumptions or put virtual instrumentation in place, we're fully aligned with the reporting mechanism that our customers are using to report into the statutory bodies. So the short answer to your question is I don't think there's a problem with the availability of data in this particular space. I think, and the power of this is that, you know, certainly at a high level, it exists, you know, at a sort of annual and quarterly basis. But what we're seeing so far is that because we're able to connect those two data sets effectively together, you know, you can actually provide that level of granularity everywhere. You can provide that high level emissions data. So I'm not sure if that answers your question.
No, that's good to hear. Brilliant. Thanks very much, Chris.
Yeah, that's great. We've got 2 minutes left in the Q&A. We've got one question here from Cameron Gordon. Is it a great one given your job title of Chief Customer Officer? So I will let Cameron ask that one himself.
Hopefully he's going to explain to me what it is.
No promises there. Thanks very much, Chris. Great presentation. Really interesting to hear what you guys are up to. So it kind of follows on from the previous one. How ready are the customers you're currently working with to start using the system? So that talks to, I suppose, data availability, but also the culture behind making it work or getting it to work and get as much value out of it as possible. How long's your lead time in there, or how quickly can it be set up? Thank you.
Yeah, so I guess that's a really interesting question. It probably comes back to some of the topics that we've been talking about already. I think from this is a complex technical challenge, and as I said, it can't be just copied and pasted from one asset to another. We've built a framework that can be customized for each asset. So once we've got an understanding of not just the availability of data, but of the operating modes, philosophies, and whatnot on each of the assets. It takes about 4 to 6 weeks to customize the software platform so that it's ready to be used by our customers. I guess from a cultural perspective, this is something that I guess we've got a bit of a track record working with customers to try and make the deployment and the adoption of this kind of predictive technology as straightforward as possible. But actually, part of our deployment approach is, taking some of those lessons, because it really is important that that the line of sight is achieved from the ambitions that are set by those in C-suite all the way down to those that are using the software platform in their day-to-day decision-making process. And the fact that it's a web-based tool and is available to pretty much anyone with a login details means that actually you can share the information and the insight. You can aggregate and disaggregate depending on the level of conversation that you're having. So actually, it's structured to help facilitate a conversation throughout the organization. And that's really, really important because, unless somebody, throughout the management hierarchy is interested in the emissions intensity opportunities and improvements that are being made by the asset, day in, day out, then adoption is going to be quite challenging, and you're relying then on those that are just interested for interest's sake. But to be frank, what we've seen is that this is a key driver for operators, certainly in the UKCS and further afield. And there is no getting away from the energy transition. And as I said, it is starting to be felt throughout the organization. And this is just about making sure that those conversations, can take place in a structured way, using, the data that's already available, to drive that ultimate value for not just the operator, but I guess for all of the stakeholders in our industry and that share the air that we breathe.
Brilliant, thank you.
Right, that's great. That's our 20 minutes of Q&A up. I'd just like to thank everyone for attending today, especially those that asked questions. I thought that was a really great interactive Q&A session. Big thanks to Chris, our speaker, for a fantastic presentation. It's a technology that I think is going to be absolutely pivotal to reducing operational emissions. If we look at OGUK's 3-prong attack on operational emissions, we're looking at operational improvement, reducing flaring and venting, and then the big state change, things like electrification. And actually, XPass for emissions, I think it's got a huge potential in those first 2 areas. There is a QR code on this final slide here for people to scan that will take you to our next Tech20, which is next Friday at 11 AM. And if you want to continue the conversation with Chris, please head over to LinkedIn and do so on that platform. So other than that, I'd just like to do one last thank you to everyone for attending. Have a great weekend and hopefully see you once again on one of our upcoming Tech20s.
Thank you for having me.
You're welcome. Bye.
Bye-bye.